In this experiment, you will be able to apply the gas laws, which I hope you have learned in your lecture class. Otherwise, I would give a simple guide on how to perform the calculations. For a short introduction, why were there gas laws developed by several scientists from way back in the 1800s? This is in connection with the development of a field of study called thermodynamics. Thermo means heat, and dynamics means changes or movement. So, simply put, it's the study of heat changes. This was important in the Industrial Revolution. Cue steam engines. Steam engines were ran by steam from heated coal. Steam is, tada, gas. So, scientists back then were curious how they could maximize the efficiency of a steam engine. So, they studied the behavior of gases. Your gas laws include Boyle's law, which related the pressure and volume of a gas, Charles' law, which relates the volume and temperature of a gas, the combined gas law, which is the combination of Boyle's and Charles' laws, the ideal gas law, with the gas constant R having a value of 0.08206 liter atmosphere per mole per Kelvin, and Dalton's law of partial pressures, which states that the total pressure of a gas composed of different species is equal to the pressures of each individual gas if it were alone in the same container. Now that you are equipped with these equations, let us go to the experimental part. You might have already read the procedure and found it seemingly complicated, but it's actually easy when you get the hang of it. We start with the carbon dioxide generator. The carbon dioxide generator is simply a big test tube inside of which you will allow a chemical reaction to take place. The test tube is secured at a 45-degree angle to an iron stand with a clamp. The chemical reaction in this experiment is a reaction of calcium carbonate with hydrogen chloride or hydrochloric acid. This reaction generates carbon dioxide gas according to the following reaction. Before we introduce the reagents into the carbon dioxide generator, let us set up the carbon dioxide collector. The carbon dioxide collector works on the basis of water displacement. A 1-liter beaker is advisable for this collector. Get a 100 ml graduated cylinder and fill it with water. It should be overflowing. Likewise, fill the beaker with water. Next, you can cover the cylinder with your hand, but a plastic film or aluminum foil might be better. Secure the cover of the cylinder and invert it. Submerge the mouth of the cylinder into the beaker and remove the cover. Check if there are air bubbles inside the cylinder. If there are, you need to repeat this step, making sure that there are no trapped bubbles inside the cylinder. Then we go back to our carbon dioxide generator. Get a sample of calcium carbonate with precise mass. Transfer this to the test tube. Weigh the remaining calcium carbonate in the aluminum foil and get the mass of calcium carbonate inside the test tube by difference. Next, you will place hydrochloric acid in a small test tube. Fill up to 2/3 or 3/4 of the small test tube. That should be enough. Now, gently slide the small test tube into the big test tube. Careful not to allow spillage of hydrochloric acid. Replace the cork stopper into the big test tube. Check the connections if they are airtight. And then slowly adjust the angle of the big test tube so that the hydrochloric acid from the small test tube can flow to the calcium carbonate. You will observe bubbles forming, and then the gas will start to displace the water inside the graduated cylinder. This reaction is very fast. When gas generation has stopped, it means the reaction is finished. Remove the rubber tubing from the gas collector. Adjust the height of the cylinder so that the level of water inside the cylinder and the level of water inside the beaker are aligned. Finally, read and record the volume of the gas inside the cylinder. Now let me guide you through the calculations. You will be able to get the moles of calcium carbonate from its mass. You need to apply stoichiometry because what you have is moles of calcium carbonate. How many moles of carbon dioxide is equivalent to 1 mole of calcium carbonate in our chemical reaction? So you should look at the balanced chemical equation. We see that the ratio is 1:1. This means that the moles of carbon dioxide generated is equal to the moles of calcium carbonate that we allowed to react with hydrochloric acid. Now, how are we sure that all calcium carbonate reacted? It's because we put an excess of hydrochloric acid. Remember the concept of limiting reagent and excess reagent. The objective of the experiment is to determine the molar volume of carbon dioxide at STP or standard temperature and pressure, which are 0 degrees Celsius or 273.15 Kelvin and 1 atmospheric pressure. Also, we need to consider the fact that the gas collected inside the graduated cylinder is not pure carbon dioxide. It also contains H2O gas. That is why it's called wet carbon dioxide gas. Since we know the ambient pressure, we can consult standard vapor pressure tables for water at different pressures. Once we have determined the pressure of water, we can subtract this from the ambient pressure. This will give the pressure of carbon dioxide present in the gas that you collected. This is an application of Dalton's law of partial pressures. Now, we have the volume of these moles of carbon dioxide under the pressure and temperature that you measured during the experiment, right? So how do we determine the volume at STP? We use the combined gas law. Say T1, P1, and V1 are the parameters that you measured during the experiment. T2 and P2 are the standard temperature and pressure. You can readily compute for V2. And once you have the volume at STP, you just divide this by the moles of carbon dioxide to get the molar volume of carbon dioxide.